We're going to start this next unit about inequalities. And just like we did with equations, we're going to start with one-step examples. So these are one-step inequalities, and then we'll go to two-step and harder ones after this. So this is a new word, inequalities, and I want to really go through this from a conceptual point of view. So walk with me through this definition. What does this word mean? Well, let's start by asking, okay, what is an equality? Well, an equality, as you probably can guess, is what we've already been looking at. They are equal, right? Equal. The word is right there, equal. So we have already been studying these equations that are equal to two things. You have something on one side, you have something on one side that's equal to something on another side, right? And the equal sign right there is what makes it an equality. So an equality says that everything on one side is equal to, which is the same as saying it's the same as, everything on the other side. Okay? Pretty self-explanatory, right? Okay. So if that's an equality, what we've already done, then what is an inequality? What is this little prefix right here? What does that little prefix mean that's different from an equality? Well, it means that one side is, that is an O, oh gosh, one side is not equal. Not equal to the other. We're going to talk about what that actually means in just a second here. So notice what n equal means. N equal, if it's not equal, then one has got to be smaller or bigger, right? One side is either going to be smaller or bigger than the other side. So remember that this is like a seesaw here. So we've got our little fulcrum, and we have our seesaw, right? We have our little board that's going this way, and you have stuff over here, and you have stuff over here. And if they're equal to each other, then this is going to be flat. But if they're not equal to each other, if they're not equal to each other, then one side is going to be tilted, right? So say that the left side is bigger than the right side. If the left side is bigger than the right side, then it's going to be tilted up like this, right? If this is bigger, then it's going to be tilted up like that. And if the right side is bigger, then it's going to be tilted down like that, because this over here would be bigger, right? Bigger. So I want you to start thinking about this from a number line point of view. On a number line, you have negative infinity down here and positive infinity way up here, and then right in the middle you have 0. What would happen if the difference between the left and the right side was 0? Well, if the difference between the left and the right side is 0, that means they're the same size. So this would be the equal situation. And then down here, if it's weighted more to this side, then this side's going to be bigger, or if it's weighted more to this side, it's going to be bigger. And if one side is bigger, then the other side has to be smaller. Okay? So does an inequality have a single solution? No, it does not have a single solution, because an inequality is unequal to just one thing. It represents a range of answers that would satisfy it. Okay, so a range of answers. So we're not just looking for, we're not just looking for x equals 4 anymore. We're looking for a whole range of answers, not just a single answer. Okay. All right. So this is really best understood by looking at some examples. Okay. So let's talk about symbols, so we can start talking about examples. You always read these from the left to the right, just like we have been doing. In English, we read from the left to the right, and so you're reading from the left to the right with this, just like you would anything else. So this is the equal sign that we're familiar with. This sign means less than. This sign means less than or equal to. Notice the difference here is that you have this extra little bar right here. And sometimes you'll see it written with the bar straight across like that. So it's kind of like an equal sign, but the top of it's been replaced with this thing. That's where it comes from. It means less than or equal to. Now I usually write it with the bar slanted, which is more of a European notation, I believe, but this is the way I do it. Okay, less than or equal to. This means greater than, and this means greater than or equal to. Again, you're just adding the little slant, the extra slant to it. Okay, greater than or equal to. Okay, and this is or, so either thing could happen. It could be less than, it could be equal to. Both are fine. Both are included in this symbol and this symbol. So how do you keep these separate from these in your head? How do you get them right and not get them confused? Well, think of an alligator. The alligator always eats the biggest thing. Okay, so if you have something is less than something else, and this is bigger, right? Then the alligator, if this is an alligator's mouth and their teeth right here, right? And then he's eating this. He's always going to eat the bigger thing. So if you were to write something like this, where this is greater than, where this is greater than this is the bigger one. Here, this would be less than. So whatever over here is less than the bigger one, because he's always eating the bigger one. So if you're just reading it across like this, then you would read this is less than this, and that less than sign is this less than sign right there. Okay, so here's some examples. 2 is less than 9, right? Oops. 6 is greater than 4. Notice the alligator's eating the bigger thing, the 6. 6 is greater than 4. You can also write operations in here. So 3 times 5 is less than 20, right? Because 3 times 5 is 15. So this is less than 20. So what would it look like if I meant x is less than 2? Whoa, x is less than 2. Well, then what could x be? X could be 1. X could be 0. X could be negative 50. All of those things. And how many more are there? There are an infinite number of things, right? Because all those things are less than 2. So if we're graphing this answer, notice we're no longer saying x is equal to 2. We're not saying x is 2. We're saying that it's everything less than 2. Everything less than 2. So that means that there are an infinite number of possible x's, right? Because there's an infinite number of numbers that are less than 2. So if we are graphing this, and I'm trying to figure out where my pen is. Here it is. If we're trying to graph this, you know, here's 2, and x is less than 2. So it could be right here. It could be 1.5. It could be 1. It could be negative 3. It could be anything over here. But it does not include 2, because if it included 2, then we would have a little equal bar right there for less than or equal to. So this is not saying that it's equal to. This is just saying it's less than. So if we're not going to include 2 itself, we draw a circle, because 2 itself is not actually included, right? It's not equal to 2. And we're going to color in everything going this way, because x is all of this stuff down to negative infinity. So all of that, not including 2 itself, is the answer. How would it be different if I said x is less than or equal to 2? So notice now I have the equal to situation also. Well, that would be easy. that would be easy. Here's my 2, right? Here's 0. Here's plus infinity. Here's negative infinity. The only difference now is that I'm coloring 2 in because x could also be 2. And then I shade this direction just like I did before. So notice the only difference here. This is where 2 is not included. This is where 2 is included. So this is x is less than 2. This is x is less than or equal to 2. See the difference? Because 2 is okay here. Here, 2 is not okay. Okay? So let's take this up a notch again. So what about n minus 6 is less than or equal to negative 14? Remember, I'm still starting when I read this. Okay, when I read this, I am starting over here, right? And I'm reading this way. I'm reading that way. So n minus 6 is less than or equal to negative 14. Well, we don't know what n by itself is. We know n minus 6 is less than or equal to 14, but we can treat this kind of like we do with a equation. So if we just imagined right here, if we just imagined for a second that we were saying n minus 6 is equal to negative 14, oh, that's easy. That's easy. I would just add 6 and add 6, and I would have n is equal to negative 14 plus 6 is negative 8. And so n equals negative 8, right? Because when I add those go away. Okay? So there's no difference here because the sign has changed. You would do the addition of 6 just like you would otherwise. The only difference here now is that we're not talking about an equality, we're talking about an inequality. So instead of n being just equal to negative 8, n is less than or equal to negative 8. So let me show you what that would be like. So here's 0, here's negative 8, and this is of course negative infinity down here. This is positive infinity up here. Okay. So if n equals negative 8, then our solution would just be, remember this is if n equals negative 8, equal, like in the old-timey equation days we were just in last week. So if n equals negative 8, then our solution would be just that one number right there at negative 8. But we don't have that. We have n is less than or equal to negative 8. And so in this case, okay, here's 0, here's negative 8, and again this is negative down here, and this is positive up here. So n is less than or equal to, so less than or equal to. So we know it's equal to, so we can fill it in there, and n is less than that, so it is everything down here. So notice the difference between if it was just equal and when it's less than or equal. Okay, it includes everything else down here. Okay, what about 12? Excuse me, negative 12 is greater than x minus 7. Well, if this was an equal sign here, I would just add the 7 because I have to do the inverse operation of this minus 7. So here I do the same thing. I add 7 and I add 7 to both sides of the inequality. But notice it's not an equal sign, it's greater than. So when I add the 7, these go away. Negative 12 plus 7 is a negative 5, and x by itself. So my solution, here's 0, here's negative 5. My solution is going to be that notice that negative 5, okay, is greater than x. So if we wrote this, if we just flipped this whole thing around, negative 5 is greater than x, right? So if negative 5 is bigger than x, then x has got to be stuff down here, right? If this is x, negative 5 is greater than x. See that? So I can actually just flip this around and say that x is less than negative 5. Do you see how those are the same statement? This and this are the same. Because here the alligator is eating the negative 5, and here the alligator is eating the negative 5. If I have little teeth right here and little teeth right here, right? The alligator is eating this, and the alligator is eating that. That's what's bigger. So I just took the whole thing and I flipped it. So x is less than, I'll do it like this, x is less than negative 5. So is negative 5 included? No, it's not, because it's not equal to right here. But it is less than negative 5, so I can go down here and do that. Okay. Now, I want to talk about one more scenario. Okay? One more scenario, and this is the only thing that is different about this and all other techniques for solving inequalities. So the only difference when solving an inequality than if you were solving an equality, okay? So the only difference is if you divide or multiply, as one of your steps. Like here, our step was adding 7. But if you divide or multiply by a negative number, notice this is just dividing and multiplying. I'm not talking about adding or subtracting. If you divide or multiply by a negative number, you flip the direction of the inequality sign. And what I mean by flip the direction of the inequality sign, if it's that way, then it becomes that way. You just take the sign and flip it. And the reason for that is that if you're dividing by a negative number, let's say I'm dividing by negative 6, okay? Well, that's the same thing as saying I'm dividing by negative 1 times 6. And when you're dividing by a negative 1, you're going through, just like in equations or any kind of the math that we're learning. When you divide or multiply by a negative 1, you just go through and you're flipping all the signs, the positives and the negative, and the positives and the negatives. They all flip to the other sign. And so that's the same with the inequality. If you're dividing or multiplying by any negative, you could really say that it's that negative 1 in there that's flipping from that sign to that sign. Okay? Or if you're starting out like this, then you're going to end up like that. They just flip. And if it's equal to, then it stays equal to. It's very, very, very easy. The only thing you do is flip the direction the alligator is facing. But if it's already equal to, then you leave it equal to. Okay? So let's talk now for some more examples. How about that? Okay. Some more examples. Here we go. Okay, so I'm looking at number 9 right here. Okay, let me actually zoom in so you can see this a little bit better. Okay, number 9 right here. Okay, so negative 3x is greater than 3. So what would our step be here? If I have if I have negative 3x, okay, is greater than 3. What is the step that I'm going to do to solve this? I'm going to divide by negative 3 and divide by negative 3, right? So here these cancel, right? And on the left, I just have the x, and 3 divided by negative 3 is a negative 1. But because I divided by a negative 3, I'm flipping the sign, and where the alligator is facing to the left, the alligator is now going to face to the right. Okay, so this was greater than, so now it's less than. So that's my solution right there. So x is less than negative 1. X is less than negative 1. And so my solution ends up being the negative 1, which is not colored in because it's not equal to, and x is less than this. So here is all of my solutions are all going this way. Okay? And so that's how you would represent your solution. Okay? What about negative x, negative 9x is greater than or equal to negative 90? Well, negative 9x is greater than or equal to negative 90. So we're dividing by a negative 9 here and here, right? So those go away. And so I'm left with an x. Over here, negative 90 divided by negative 9 is a positive 10. And because it's a negative 9 that I'm dividing by, I have to flip this sign. So it's now going this way, and it is still equal to. Okay, so there's my solution. So x is less than or equal to 10. So here's the 10. And in this case, I'm filling it in because it's also equal to, because it's equal to right there. But x is less than this, so it's all of this stuff going all the way down here. And notice that I get the arrow also because it keeps going even though the number line stops on the picture itself. Okay? Here's another example. Let's do this one right here. 32 greater than or equal to negative 16p. So 32 greater than or equal to negative 16p. And I'm dividing by negative 16 so that those go away. Okay, so 32 divided by negative 16 is negative 2. So on the left we have negative 2. I'm flipping the sign because it was a negative 16, so the sign is now going like that. Do you see how that happened? They're flipped signs. And on the right I just have p. Now this is a little bit backwards from what we would like to see. This says negative 2 is less than or equal to p, but if I flip this around, just so I can read it better, notice that the alligator was eating the p, right? So the alligator needs to keep eating the p. And these are I just want to be really clear. These are exactly the same thing. Okay, those are the same thing. It's just easier to have the variable on the left so that when you read it, you go p is greater than or equal to negative 2. Okay, so here's negative 2, and it is equal to, so I'm going to keep it equal to, and p is greater than or equal to. So it's greater than or equal to. So it's going up to the positive, and it keeps going. Because again, anything up here is still going to be greater than or equal to negative 2, right? I just need to know where it starts. Okay, so that is that. And next we're going to be doing some more complicated examples that take more than just one step to solve.